Hello everyone and welcome to another Bytes University video. Today we're going to be talking about masking. For this example, let's say that we have our output B and we have 8 bits of B and we want to set bit 4 to 1 and leave the rest the same. That means that if bit 7 is a 0, we leave it as a 0, and if it's a 1, we leave it as a 1. How do we do this? Well, for masking we have two options. We can either use or and. If we use or, we can look at our tables. You have these options of output, and if you have and, you have these options of output. So we know that we want to leave 4 as a 1 and set it to 1. Notice that it's a little bit easier to set an output to be 1 with or than and. So in this case, we're going to be using or. That means that B or equals our mysterious answer. So for 4, if we want to set it to 1, that means that no matter what 4 is, we want to make it a 1. Well, if our mask is A and B is our 4 pin, our 4 digit, it doesn't matter what that is, we need the output to be 1. So in this case, if our mask is a 1, doesn't matter what B is, we'll get a 1. However, if our mask was 0, we would only get 1 if 4 was already 1. So that's how we know that we're going to mask 4 with bit 1. Now we have a bunch of other unknowns, and we want to leave everything else the way that it is. We don't want to change it. We don't want to set it to 0, and we don't want to set it to 1. We want to leave it as whatever it already is. So if we take a look at our ORs, notice that whatever B is, we want to leave that the way that it is, right? 1, 1, 0, 0, they match. If we mask it with a 0, we'll leave it. That means that 5, 6, 7, and 0 through 3, we're just going to leave those as zeros. So that means that in order to change the 4th bit, the 4-bit, not the 4th bit, the 4-bit, to a 1 and leave the rest as it is, we're going to mask it with B or equals, or equals, and then we're going to write this in hex, right? So this in binary is what? It's 1, right? Because you only have 1 pin. 1, and this in binary is 0. So that's our answer for making pin 4, bit 4, a 1 and leaving the rest the same. Now, what happens if after you do this, you want to make the rest of them zeros? Well, that's a little bit different. Now we know that pin 4 is 1. That's already set. And we want to make the rest zeros. We want to make this 0. Everything else zeros. Well, what do we mask it with? Well, we're going to do a second mask. Our first mask, that's a 1, 1, 0. That sets pin 4 to 1. This is going to set the rest to 0. That's going to be, well, if we take a look at our tables again, notice that it's easier to get a 0 from anding it than oring it. So that means that we're going to and it. If we want to make the rest of these zeros, that means that no matter what this is, no matter what our pin is already, we can just and it with a 0, and that makes it 0. So that means that we're going to and the rest of these with 0. So that's pin 4. Cool. So we now have set the rest of these to zeros, and we want to and this, and we want to leave 4 as a 1, because remember we just set it to a 1. We did all that hard work. We want to leave it as a 1. That's pretty simple. Notice that if bit 4 is a 1, no matter what pin 4 is, we can leave it the same, and we'll leave it the same by masking it with a 1. So to wrap this problem up, B and equals, and then again, we're going to use binary. We're going to use hex. That's going to be 1 and 0. 0, x, 0. So to take the output B and make the 4th pin a 1 and change nothing else, we're going to OR it with hex 1, 0. If we want to set pin 4 to a 1 and make everything else a 0, we're going to first OR it, and then we're going to AND it. And that's a little bit on bit masking. Thanks for watching.